Welcome to Microlecture 5, where we discuss functional groups. Functional groups are groups or clusters of atoms that have particular characteristics. We can know something about the reactivity of a molecule if we can identify the functional groups present and then know something about the reactivity of those functional groups. And it looks like a lot of them, but you're already pretty familiar with the hydrocarbon functional groups because we've been talking about them. So alkanes, alkenes, and alkynes. Those are your single bonds, double bonds, and triple bonds respectively. And then we have phenyl groups, or benzene rings. So I want you to notice that there's a group of functional groups that contain just single bonds, and these bonds are always between carbon and a more electronegative atom like nitrogen or oxygen or a halogen. So these groups are the amine, alcohol, ether, alkyl halide, and thiol. The other functional groups all have carbon-oxygen double bond, otherwise known as a carbonyl, and those are the aldehyde, ketone, ester, carboxylic acid, and amide. Please spend some time drawing these out and just learning their names. Two more groups that you should know are the nitrile and the nitro group. You'll notice the use of R here. We use R a lot just to mean the rest of the molecule. So like in the previous slide where there was just a line and we would presume the rest of the molecule is on the other side of that line. That's how we use R. R can be any carbon-containing group. So pause the video here and go ahead and test yourself. Circle and hunt for as many functional groups as you can in this molecule of doxycycline. Okay, so here's what I found. I've got a carbon to an OH group, so that would be an alcohol. And let's kind of look around and see if there's any other alcohols. I guess I'm seeing one there. That one's kind of unique because it's a pretty reactive functional group called an enol, since it's sitting on a double bond. But there's another alcohol, and I found another enol. So these are all alcohols. Alcohol. Alright, and so I'll circle all of the alcohols in purple. And I'm seeing a carbon-oxygen double bond, and there's nothing adjacent to, this carbon that's doubly bonded to the oxygen. That's what we look for to see which kind of carbon-oxygen double bond functional group it is. By nothing next door, I mean carbons. So it's not nothing, but rather carbons, right? So that makes this a ketone if you compare to the slide with functional groups. And so same thing here. I've got a carbon-oxygen double bond. Neighboring atoms to this carbon that is central to the functional group are just a couple of carbons. So I'm going to call that a ketone. And here I've got something different. Here the adjacent atom is not a carbon, it's a nitrogen. That makes this functional group an amide. And then we've got a nitrogen containing group here, and it's an amine. And amines can come in a few different kinds. So you could have a couple of hydrogens on the amine and just some R group over here. Or you could have one hydrogen and then maybe another R group. In this case, we've actually got no hydrogens on it, and so we've actually got 3 carbon-containing groups around that nitrogen. So that's interesting, and we'll later on we'll go ahead and call that a primary amine, a secondary amine, and a tertiary amine. Other than that, it's all hydrocarbon, and so we do have a benzene ring, worth noting there. And as I was saying before, adjacent to these two alcohols, we have a carbon-carbon double bond, or an alkene. Okay, let's do that again, but with penicillin. Okay, so here I went ahead and circled everything already. I see a phenyl ring, so that's a benzene. I see a carbon-oxygen-carbon connectivity, so that's the ether. I see two amides, one of which is within a cyclic system, so that's kind of tricky. And I see a carboxylic acid, which is a type of carbonyl. And that's about it. There is a sulfur-containing functional group, but it was not one of the ones that I asked you to know. It's not a thiol. Thiols have a hydrogen on the sulfur, so this one's called a sulfide. And that's it.